Okay, in this video, I'm going to discuss other factoring techniques. And remember in my introduction video, we discussed how factoring was the opposite of distributing. All right, and I'm going to focus on this type of problem, okay, where we distribute a binomial to another binomial. All right, so when we're factoring quadratics, just like when you're using quadratic formula, we have ax squared plus bx plus c. We call a, b, and c those coefficients just to keep track of them. And what I'm going to split this up into is I could have my a value be 1, or a value can be something other than 1. All right, and the reason I'm doing that is because when a equals 1, these are the easy ones. These are very easy to factor. So that's what I'm going to talk about in this video. Notice that when I'm factoring, this type of strategy is working when I have a quadratic trinomial. So quadratic means, right, I have the highest power is 2. Trinomial means I have 3 terms. Okay? So let's look at this. So reminder, when we are distributing, we're distributing that first term to both of those terms in the second binomial. So that's x squared plus 7x. And then I have 5x plus 35. And in our distributing process, we also combine like terms. So I have 7x plus 5x is 12x. And then I have 35. So when I'm going backwards, so when I'm starting from here, here's my thought process. I got this number, this constant number, the 35, that came about when I did the 5 times the 7, yeah? So I'm looking for 2 numbers in my parentheses. I want these 2 numbers to multiply to give me that 35. Okay, and since 35 is constant, these 2 numbers have to be constant. They will not have x's in them. Okay, so that's one thing. So I'm thinking about what are the combinations that I could have to multiply to give me 35. Well, I could have 1 times 35. I could have 2 doesn't go into it, right? 3 does not go into it. 4 does not, 5 does. Okay, so 35 is a nice number because it only has 2 sets of factors. Now keep in mind that I could do this, right? And we'll get into different orders and whatnot. But in this situation, these are all positive numbers. And so both the addition and the multiplication is commutative, so it doesn't matter what order I put it in. All right, so I know automatically that these 2 spots right here, these blank spots, are either going to be 1 and 35 or 5 and 7. Now we know that it's 5 and 7 because we already started with the answer. All right, so how do I figure out which of these is going to be the correct one? So now we look at this middle term, the 12x. How did we get the 12x? We got the 12x when we combined the 7x plus the 5x. And how did we get the 7x and the 5x? We got that when we distributed an x to each of those constant numbers, right? So 7x came from this one, and then the 5x came from this one. Okay, so we call those the inners and the outers. I don't know if you learned FOIL or not. Okay, the outer ones, that was the x times the 7, because those are on the outermost. Okay, and then 5 and the x, those are the inners. They're the closest ones. Okay, so those are the inners and the outers. So if I say check your inners and the outers, this is what I'm talking about. All right, so 7x plus 5x is what gave us the 12x. Okay, so let's think about that. How would that help me in this situation? Well, if I had 1 and 35 in those spots, then I would be adding 1x plus 5x, or 35x. And I know that 1x plus 35x is not 12x. I know that 5x plus 7x is 12x. So I know from both of these numbers, so over in the red I had my options, and then the middle term helps me determine which option is the correct one for this problem. So I know that this is going to be 5 and 7, or it could have been 7 and 5. And then again, these first numbers, so the F stands for first, that came about when I did the x times the x, right? So that has to be x, right? So when I have x squared, the only way I could have gotten that is by doing x times x. So I know that these had to be variables and no numbers in front of them. Okay, and since, like I said, everything was positive, I know those are both positive numbers. Okay, so that's the long way, that's the thinking out, that's the why behind it. Okay, let's do another one, just so we get the hang of it. So we're starting fresh, right? We don't have the answer in this one this time. So what do we do first? I'm going to look at this constant and then ask myself, what two numbers could I have used to get 42? All right, and you can probably do this in your head quite quickly, especially when you get the hang of it. But let's say you're stuck and you don't know what to do. Just start listing your factors. I start with 1 and 42. I'm just going to put a comma. I know that they're times. No, I'll just put times. And I'm not going to use an x. I don't want us to think that it's the variable x. So I could have done 1 and 42. Let's see, 2 and 21. Let's see, does 3 go into it? 3, yeah, 3. It's going to be 1, 4, 14. 4 is not a factor. 5 is not a factor. And then we have 6 and 7. Now I know I can stop because my next number in my list would have been 7, and I know that that's 6 times 7. So as soon as I start repeating and going backwards, I know I can stop, so I don't have to list anymore. Okay, so these are my possibilities. So we have to narrow those down by using our middle term. Okay, so our middle term is 13. So again, everything is addition or positive, so I know that all of these numbers would be positive. So 1 plus 42, that's not 13. 2 plus 21 is not 13. 3 plus 14 is not 13. So 6 plus 7 is the only one that gives me 13. So I know in my parentheses that this would have been a 6 and a 7, and my first terms in each would have been an x, since this is just x squared, and then since these are all positive, those would be positive. Okay, so shortcuts, right? So I don't want to have to necessarily think through all of that every single time. I think it's good to understand where things are coming from, but shortcuts are always nice. All right, so if the coefficient of x squared is 1, and that's what we're talking about in this video, then we're going to have x squared plus bx plus c equal to x plus m times x plus n. Do you notice how the x's are the same, right? Because we just have x times x is x squared. And then the m and the n are those two numbers that we've been talking about. And remember, we said m and n multiply to give you c. So m times n is going to give you c. And then when I add m plus n, I'm going to get b. So here's another question, another way we can approach this. What two numbers multiply to give me 21 and add to give me negative 10? Now, keep in mind, this is a negative, right? This is a positive. So now my two numbers have to either be both positive times positive is a positive, or both negative. Now, if I add two positives together, I'm not going to get a negative number. But if I add two negatives together, I will get a negative number. So keep in mind, our m and our n are going to be both negative. Okay, so keep that in mind. So what are the possibilities for 21? And again, you could do this in your head. You could be like, okay, 1 and 21, does that add to give me 10? No. 2 doesn't go into it. 3 and 7? Yeah, that works. So I know right away that I'm going to have x and x, and then I'm going to have 3 and 7. But here's the thing. We said that 3 and 7 had to both be negative in order for this to add up to be negative 10. So I need to put a negative 3 and a negative 7. So it looks like x minus 3 and x minus 7. As always, you can check yourself just to make sure you're doing it correctly. So when in doubt, check yourself. So on a test, you always know if you've done it correctly. Okay, so again, why are we doing this? Remember that the whole point of this is to solve a quadratic equation. So if I know this quadratic is equal to 0 and I factor it, if I can factor it, which as we just did in the shortcut, it wasn't really that long of a process, a lot quicker than the quadratic formula. And then we said our zero product property says that each parenthesis equal to 0, so each factor equals 0. This time I have binomials, so I'm going to set each of those binomials equal to 0, and then I'm going to solve each equation. So I'm going to get x equals 3, and over here I'm going to get x equals 7. So those would be my two answers to that quadratic equation, and that's where my parabola would be crossing the x-axis. All right, so here's your turn. Pause the video, try them, see if you can get the right answer. Okay, so here are the answers. If you got them right, awesome. If you didn't get them right, here's some things to think about. If this 9 is negative and this one is negative, remember if I have two numbers multiplying to give me a negative number, one's negative, one's positive, right? So if I'm adding them together, so I know my numbers are 9 and 1. So think about that. If I know that one's positive, one's negative, I'm really looking to see if they subtract to equal 8. So 9 minus 1 equals 8. As far as which one gets the negative sign, I want it to be a negative 8. So I need my larger number to be negative and this one to be positive. Again, it doesn't matter if you had x plus 1 first and then x minus 9, because multiplication is commutative, but addition or subtraction is not. So I want to make sure that you are putting the negative on the 9 and not the 1. All right, same thing down here. This 48 is negative, so that means I'm going to have one positive number, one negative number. However, this time they're going to add to be a positive number. So once you figure out that I'm doing 8 and 6, okay, because 8 minus 6 is going to give me that middle number 2. But I want to make sure that I have a negative on the 6, a positive on the 8, and not vice versa. So it's again, it's okay to switch the order of the parentheses, but it is not okay to have x plus 6 and x minus 8. That is not correct. All right, I want to show you one more thing in this video, and that is this one. Actually, I'll do that in another video.